Next up, let's move on from oxidation now.
Iodoform reaction.
Before we go to those guys over here, let's go for Lucas test.
Okay.
What did you understand in Lucas test?
It's like the turbidity forming. Just like whether the thing is soluble. Like how do I exactly
Summarize Lucas test, Ra.
so basically we're reacting an alcohol with this HCl and ZnCl2 anhydrous. So if the reaction does take place, then alkyl halide is formed, and the alkyl halide is not soluble in water. So like if the thing becomes turbid, that means RCl is there. That means the reaction happened. That means the alcohol is there. So it's identification type for alcohol. And then for 3 degree, 2 degree, 1 degree, it's like different. Like the rate is different, rate of reaction. So you can compare along those lines as well.
Okay. So the test over here is that you're going to be getting what exactly?
Alkyl chloride.
Alkyl halide, which comes out as
Turbid precipitate.
white precipitate.
Yeah.
So let's first quickly talk about what is going to be the mechanism involved here, and then talk about the next bit there. So when it comes to the reaction mechanism here, the reaction mechanism is going to be deciding what is going to be the products and the test results. So let's first look at the test results, then we'll understand the mechanism from there. So the test here is very simple. ROH plus concentrated HCl in the presence of anhydrous ZnCl2 is going to be producing RCl. Right? So the RCl comes out as a white precipitate. Correct? So this white precipitate is going to be, observation of this white precipitate is the test over there basically. Now let me put down the results over here. So 3 degree ROH or benzyl ROH. These basically give immediate white precipitate or immediate turbidity. Okay. Next up, secondary alcohol. What is the observation?
Slower formation of turbidity.
Any other observation or there anything else to add there?
No.
We need to heat it also.
Oh,
all right.
But only for 1 degree or 2. Okay.
So for secondary alcohol over here, you will have to heat this fellow over here to basically have a chance of getting the thing here. 1 degree ROH. What's the observation?
Like after a long time, and then you have to heat a lot. No reaction.
Yeah.
So
That
they
is
were
a
given.
general accepted thing. Don't take it as after a long time. Take it as no reaction, please.
Okay.
Okay. And you're going to be having methanol, obviously, will be 0 degrees, only one fellow there. Methanol only. Methanol also is no reaction. Now, what is the idea over here? How is this reaction supposed to be going here? If it is going to be giving you this kind of scenario here, quite clearly, mechanism has to be carbocation mechanism.
Yeah, exactly.
So, if it is a carbocation mechanism, what is going to be happening here in this particular case here? You're going to be having rearrangements being definitely possible. Right? Because it's going to be involving carbocations. And in this particular case here, if you're going to be having what to say carbocation here, rearrangement is possible. Heating is also because of carbocation effectively. The heating is also basically because the carbocation is going to be requiring some activation energy to form. The heat will basically supply that energy to basically get the carbocation in good shape. That is going to be one of the things there. Now, let's talk about a couple of other points over here. First of all, why do I need anhydrous ZnCl2? What is the other product, by the way, other than the RCl?
Water.
So, what is the role of anhydrous ZnCl2? What is the role of concentrated HCl? What's the idea here?
1 minute. Sir, if it was hydrated ZnCl2, then there's a chance of that reacting rate, the H2. But wait. So the concentrated HCl is for the H plus generation.
Good.
Yeah. And then you want high concentration of that. So that,
ZnCl2 is also for that only actually.
oh,
Because when you want H plus generated over there, you need something else to accept the Cl minus. Na?
oh yeah, correct. Yes.
There is no water now in this particular case here. Somehow or the other, we have to stabilize the Cl minus. The Cl minus normally will be stable because water will be present.
Okay. Yeah.
There is no water here. So you're going to be having to require something in the medium to stabilize your Cl minus. So what happens
sir.
over there is you'll end up having Cl minus combines with your ZnCl2 to basically exist as ZnCl4 times 2 minus. So zinc ends up forming a chlorido complex over here like this, ZnCl4 times 2 minus, which stabilizes the Cl minus. That's the role of your zinc in this particular case. Now, in this particular reaction here, you're going to be having fairly straightforward reaction mechanism. You'll have H plus, you'll get what to say water molecule eliminated out, and your water molecule can also form zinc wala complex. It can form ZnH2O4 times 2 plus. Right, so water can also form this complex. So you'll have both complexes technically available. Doesn't matter which one is what to say happening there, but the reality is you'll end up having reaction mechanism being something like this. Tertiary alcohol and benzyl alcohols will give immediate white precipitate, immediate turbidity, and they will give it at room temperature itself.
Okay. Sir, this ZnCl2 aqueous also applicable. This
ZnCl2?
aqueous. Sir, not aqueous. I mean, in the presence of water. This entire reaction in the presence of water.
This water is also going to get trapped away by the ZnCl2 in this fashion.
Yes, sir. Yeah, I got that. But then, like, if we didn't have a, you said the Cl minus basically should be stabilized, right?
Cl minus is getting stabilized by the ZnCl2, yes?
Yeah, but like if ZnCl2 was not there.
That's why using anhydrous, ra. In the reaction, we use anhydrous ZnCl2, na? Have a look. If I had it hydrated, the Zn will basically go off like this. with water. You want to avoid that happening. So we make sure we use anhydrous.
Okay, okay, okay. My bad. Okay.
Okay, yeah.
Yes,
And
sir.
in this particular case here, you're going to be purposely using anhydrous so that you're going to be having the ZnCl2 properly existing with and taking off the chloride ions.
Hmm.
Okay, now coming back to the Lucas test over here. Huh, where were mechanism there? You're going to be having what to say, H plus attack happening first. You'll get ROH2 plus 1 formed over there. The water molecule gets kicked out, carbocation is formed. That is when the rearrangement can happen. Aman?
Hmm. Yes, sir. Yeah.
So when your carbocation is formed, rearrangement is very much possible here.
Yeah.
All right. And when you're going to be doing it for the secondary alcohol, you use a water bath usually, or sometimes an oil bath as well. If you want
Okay.
to get it in the primary alcohol, I'll give you the temperature ranges which are required over here. For secondary alcohol, the temperature range required is going to be like 80 degrees to 90 degrees
Okay.
Celsius. All right. So this is going to be the minimum temperature required. So this is going to be possible by water bath.
Hmm.
So if we are using a water bath, it will definitely give the product here. Now, 1 degree alcohol, why did I say no reaction? The main reason is because 1 degree alcohol, Kelly, if you want the reaction to happen, you need the carbocation formed.
Yeah.
Primary carbocation is generally formed above 110 degrees Celsius. All right. So with water bath, no reaction.
Okay.
But if you use an oil bath, you'll have reaction. You understand what is happening there?
Hmm. Okay.
Oil bath, na, if you end up somehow or the other pushing the temperature above the 110 degrees Celsius, then you will have a chance of 1 degree alcohol also giving you white precipitate. It will take a long time, but there is a possibility of it happening.
Hmm.
You
So does
understand
this
the
have
idea?
anything
Hmm?
like oil and water, like anything to do with a specific heat, like something like that?
No, it has to do with the boiling goddamn points. Think for a second.
Oh yeah. Sorry, sorry. Correct. My bad. Yeah.
Good bugger. Sometimes you have to think basic.
Okay, okay. My bad, my bad.
Thinking, overthinking shit, specific heat, it seems. Uh, this is
Okay, man.
boiling point. Water
Yeah,
boils
it's
at 100 degrees Celsius. So
yeah.
water cannot be used for anything around 95 plus. It is not going to be feasible. So if you want to go above 100 degrees Celsius, you simply cannot use a water bath.
Yeah.
You use an oil bath, or you use an oil bath in that particular case. So when you
Yes.
use an oil bath, yes, it works. To what is after a very long period of time, proper heating. Water bath, no chance.
Okay.
Now, this is going to be your Lucas test. Okay. Now, what else? Lucas is over. Okay. Victor Meyer's test. I think these ceric ammonium nitrate and these guys are okay. Those are not a problem. Victor Meyer's test. Let's talk a little bit about Victor Meyer's test. What did you understand by that?
So I mean, uh, first like the it was like a series of reactions. Like, first it was that with PX3 and then P
Okay.
PI3. Okay, wait. PI3 and then AgNO2 and then
So
NO.
let's talk about the series of steps. So what are the steps done first? We hit
First
this with PX3 first,
PI3. Yeah.
PI3. So you get RI. Then what do you do?
Then AgNO2.
AgNO2.
Sir, why exactly are you using AgNO2? I mean, next I know like tautomerism will occur, like, or hmm.
You tell me. After this step, we will come back to AgNO2 in a bit. Tell me after this step first, what happens next?
So the example we took was RCH2OH. So like oh sorry, no. Here and then
1 second. After RNO2, what happens?
that thing, 1 second. HNO3. No. H2, no. That's it. Yeah, HNO2, my bad.
What is that?
HON double bond. That. Yeah, exactly.
Oh,
Yeah.
okay, all right. Now let's start discussing each part here. I'm assuming this part is okay.
Yeah.
AI3.
Yes, sir.
Now AgNO2. What is happening here?
Acid base. No. Not acid base. My bad. Sorry.
What is
Um,
the reason why the reaction happens?
flexibility. Forward reaction probably fail.
This is a precipitate. AgI is a proper precipitate.
Yeah.
Okay. So in this case here, silver iodide is very stable precipitate. Yellow color.
Okay.
And it is highly insoluble also. Okay. So
Hmm.
this precipitate is the reason why you end up using this reaction here, AgNO2 there. Okay. And you want the nitro cell, you want the nitro basically to go there, so you do this. Easiest option to get it done. Now let's talk about what is going to be happening in the RNO2 stage there and what happens afterward. So let's say I'm going to be having a primary alcohol. Okay, let's say I'm taking primary alcohol. This guy is a primary alcohol here. Ethanol is a fellow there. Ethanol, if I'm doing the reaction, the Victor Meyer's series of sequence of reactions over there, I will be finally at this stage here.
CH3, CH2, NO2.
I'll have like this. So this is my species right now, correct?
Yeah.
NO2. Now, if I'm going to be doing NaNO2 HCl here, this will generate what? We talked about
HNO2.
this already. This generates HNO2.
Yes, sir.
In turn generates what?
NO plus.
NO plus.
NO plus. Yeah.
So this is called as your nitrosonium ion. So this nitrosonium ion is going to be the guy who is going to be an electrophile right now. So this electrophile will go displace some other electrophile, right? Electrophilic substitution karega,
Yes, sir. Yeah.
right? What substitution can it do? In this molecule, which guy can be substituted by an electrophile? Hydrogen. This is the fellow which can do electrophilic substitution. Yes or no? Nothing else is possible to be substituted here.
Yes, sir. Yeah.
So we have that guy getting substituted. So we get carbon, carbon. This hydrogen will remain intact. I will have an NO here and I will have an NO2 here. Okay. So this compound is called nitrolic acid. Now, the idea here is that this hydrogen is an acidic hydrogen. Why is that hydrogen going to be an acidic hydrogen?
NO2,
Well,
NO
very
both.
simply put,
Okay.
if you have a C minus here, then there is an NO ready to stabilize it, and there's an NO2 also ready to stabilize it.
Yes. Yeah. That's nice.
So you can have resonance stabilization like this.
Hmm.
So this is an acidic hydrogen here. This is called as nitrolic acid. That's the game here. Next up, if you're going to be doing for a secondary, what will you be getting there? If you have a secondary alcohol, you start off with this guy first. You get this nitro. In this nitro here, when you react it with NaNO2HCl, you understood Victor Meyer's test fully, or you did not understand it? Or am I doing this just for the sake of doing it now?
No, sir. I understood.
No, if you understood it in school itself, then I don't need to do it now. No?
Yes, sir. I mean, it was okay, sir. Yeah, you don't need to do it. It's fine.
I don't need to do this, is what you're saying.
Yeah. I mean, yeah.
Since I already started, I'll wipe it out anyway.
Okay.
This will generate your NO plus, which will basically go and replace this hydrogen, giving you a compound which looks like this. What is this compound called?
This just now.
Hmm.
Night.
This is called pseudo-nitrolic acid
Okay.
because this is not an acid.
Yeah, because there's no acidic edge.
Yes. So this is what happens for a secondary. Tertiary, will give you this. This nitro will be formed, but NaNO2 plus HCl will give you no reaction. This is basically the idea here. This is your Victor Meyer's test at the end of the day. You got the colors available in your school there. I'm sure your teacher has given you the colors there, yes?
Yes, sir. Yeah.
So how do you get the colors? You basically end up adding basic medium to the ending. Once you got the
NO2.
nitrolic acid, you add basic medium to it, you get your color. And the pseudo-nitrolic acid also, when you add a basic medium to it, it gives some other color.
So nitrolic acid is the name of that specific thing, or like that the type of.
This type of system is called nitrolic acid.
Okay, fine. Yeah. Hmm.
Yeah, this type of system is called nitrolic acid.
Yes. Sir. Yeah.
Okay, all right. Now, that clears off Victor Meyer's test also. Last up is the really main thing, iodoform reaction. Haloform reaction is something which is a very important reaction, mainly because it is asked enormous number of times in JEE Advanced. Enormous number of times, literally.
Hmm.
It is asked very frequently in JEE Advanced. It is a very standard thing which gets asked around. Now, when it comes to haloform reaction, you need to know the mechanism inside out for the overall thing. Did you do the mechanism first?
No, sir.
Looks like your teacher is doing justice this time. So let's start off with what you should know for this chapter and just discuss that. I'm guessing your teacher also did something along those lines.
Yeah, he gave like few points. That's it.
You will be diving very deep into this enough number of times later. So do not worry about that for now. Okay. Okay. So let's say I'm going to be having an alcohol or an aldehyde actually. Any of them will work like this. So I can have an aldehyde of this type, or I can have an alcohol of this type. Okay. If I have something like this, now there are variations also allowed in them. This and this, the CH3 parts over here can be any variation among the following. It can be CH3, it can be CH2X, it can be CHX2, it can be CX3. Any one of these variations it can be. Okay. If it is an alcohol, I absolutely must have a hydrogen on this particular location here, along with the alcohol.
Okay.
Or it can be an aldehyde like this. Yeah.
Yes.
These are my initial starting reactants. These guys, when we are reacting them with I2 in the presence of basic medium. Okay. So now this is going to be the, what to say, bare condition which you need, but they will not give you necessarily in these formats every time. And I say I2 in basic medium, they can give it to you in many different ways. So this I2 here can be something where the I2 is generated during the reaction and then basic medium is present. Or they can give you the combination of whatever is going to be the product obtained over here. When you have I2 in the basic medium here, you're going to be having reaction basically being what? This is going to be dilute basic medium usually. Okay. Sometimes you'll also have concentrated basic medium, but you'll have iodine in basic medium generally. There are many different ways in which this mixture can be given. Instead of giving it as I2 in basic medium, they can give it to you as NaOI. Or they can give it to you as CaOI, or rather they can, what to say, how to put, they can actually give it to you directly as calcium hydroxide and I2. That is also feasible.
Okay.
What is the format in which your teacher gave you?
KOH plus I2.
KOH plus I2. So he directly gave you I2 and KOH, I2 plus OH minus only.
Hmm.
Okay. There are other ways also in which, yes, sorry?
Nothing, sir.
Yes, you're saying something?
No, I won't say.
Okay. So there are quite a few other ways in which the same mixture can be given to you. You will find a whole different bunch of them as you are proceeding on. When you are learning more and more of the chapter, you will find that this I2 and basic medium can be given in many different ways. So they'll play around with how else to give it in different ways. What is going to be the reaction there? The reaction is going to be a very complicated one. We will discuss that in full mechanism in detail when we have to discuss it. For now, it is not time to discuss. What is going to be the product though? The product is going to be CHI3. Okay. Now, this is going to be the case if it's going to be iodoform reaction. If it is haloform, you'll have X2 and OH minus. Or different ways in which X2 and OH minus can be given, that will be given. And in the case of X2, you will be getting CHX3.
Okay.
Now, one or two key points about this here, about this thing here, CHI3 here, this is obtained as a yellow color precipitate. So haloform is a proper yellow color precipitate. CHX3, not necessarily a precipitate. Iodine it is a precipitate. Chloroform and all is not a precipitate.
Okay.
Okay. So this is going to be the reaction here. What happens to the leftover other part over there? That becomes a very interesting type of scenario here in this case here. So if you're going to be having the reaction considered here, this part over here is what is going to be becoming the CHX3. This CH3 bit here.
Yeah.
And you will end up having this part over here basically becomes the carboxylic acid type of system there.
Yeah.
Okay.
Hmm.
You understood or not? So if I have
Yes,
say R over here attached, I'll be having this part becoming COH. So I'll give you the product here. I'll show you a little bit more carefully. So if I have say CH3, CH, OH, and then R. Okay. If I react this fellow with KOH and I2, what will I be getting as a product? I will definitely get CHI3
okay.
as a precipitate. But along with the CHI3, I will also be getting R, CH, R, COH, sorry, R, COOH. Okay, this fellow will basically end up becoming a carboxylic acid. It will originally become an aldehyde and then it will become a carboxylic acid.
Okay. Fine. Yeah.
Okay. So it will actually become not COH, it will become CO minus.
That's
Basic medium.
okay.
We'll discuss the mechanism when we have to discuss the mechanism.
Okay.
For now, this is enough.
Sir, it's an identification test for aldehydes and alcohols.
Yeah, aldehydes and alcohols.
Okay.
So the alcohol in the reaction here actually becomes the aldehyde in the first step. And then the aldehyde performs the reaction actually.
Okay. Yeah. Yeah.
Okay. So that brings me to a close of whatever I wanted to discuss. What else is left over to talk about? Anything else to discuss for today?
No, sir. That's it.
Any doubts?
No, sir. Nothing else.
How is your preparation coming along? Otherwise,
Yes, sir. It's fine. Physics is kind of shaky for now. Like doing capacitors right now. And then that's like, yeah.
is it coming good?
Not very good, but I'm still working on it. So I still have a few more days. Yeah. Gotta get that fixed.
Okay.
Yeah.
You have a tough journey ahead, Ra.
Yes.
I already told you a long time back itself, it's only work, work, work from here. Plan properly and work. You have any other doubts with respect to chemistry preparation? Any things that you want to discuss?
No, sir. Nothing else.
Then we'll close the session here then today then.
Okay, sir.
Bye-bye. Any general doubts? Have you worked on any questions?
Questions? No, sir. Not yet. I've not started questions.
Any information about the ranks from your institute?
Oh, sir. Madhapur Samagya got 13th rank.
13.
Yeah.
In
That's all I
Khatri,
know.
Madhapur.
Yes, that's all I know so far.
Very nice.
Yeah. He was not the one who got 300 in mains.
Yeah, he will not be.
Yeah, you told last time.
You understand the reality now, na? The guy who's gotten 300 in mains, what is his rank?
I'm not sure about that.
He'll be like around 1400, 1200, maybe
Uh,
200, maybe 300.
Yeah, I'll ask. Sir. Yeah. I'll try to
Find
find
out. I'm curious.
Yes, sir. Yeah.
Because that is how the reality will be.
Yes, sir.
And I'll be very surprised if that kid has gotten under 100. Sincerely. How many under 100s do you guys have for Gila Indra this time?
Not sure, sir. All I know is 30th rank. Yeah.
13th rank is here though.
Yeah.
Nice, nice, nice. In your campus or the Madhapur campus?
Madhapur campus, sir. Our campus, I'm not sure about that yet.
Okay, knowledge. Okay, bye bye.
Thank you, sir. Yeah,
Nice.
have a nice day.
Have a nice day.
Bye, sir.
Bye.